Hi, Dr. Cap. Travis White-Velez here with this week's Advanced Interactive Concept presentation. For this week's presentation, we will be utilizing acetacetic acid, which is found in vinegar, as we've learned from a few weeks ago through the acid-base chapter. Acetacetic acid is a very weak acid, and we will also be utilizing sodium chloride or table salt to deoxidize or clean pennies without utilizing any forms of scrubbing. For this experiment, we will obviously need pennies. We will need nuts, various sizes of measuring cups. We will utilize a bowl, salt, vinegar, and also water, which is not pictured here. Stay tuned and I will be conducting the experiment. And while conducting the experiment, I will give some definitions and why what you're going to see in the experiment happens. Now that I have my supplies and everything ready, gathered the water, we're gonna go ahead and mix the acetacetic acid and the salt together. So we're gonna take 1 teaspoon of salt. We're gonna put that in. And we're going to take 1/4 cup of vinegar or the acetacetic acid. And we're going to mix until that is well combined. So a little bit of background kind of about this. Pennies are obviously made of copper, and the older the penny, the greater the composition of copper, or the greater the percentage of copper that's actually found in the penny. When copper is out in the environment, there's obviously air. There's obviously oxygen within the air we breathe. When copper and oxygen interact, they form copper oxide, which is the combination of oxygen and copper, as I just stated. That process is actually slowed when pennies or copper is placed in water, but it does take significantly longer than if it was placed inside an acid, or in this case, a weak acid. This weak acid actually helps to kind of break down the copper oxide, and it forms what's known as blue copper 2, I believe. Blue copper, 2, which is an ion that actually is soluble in water. And you'll see at the end of it, the penny will actually become nice and shiny again and look just like a brand new penny. So we're going to go ahead and drop the pennies into the solution. And you can see it's starting to react. All right. So the longer the pennies stay inside of the acetacetic acid, the cleaner and shinier they will come out. But after we take them out of the acetacetic acid solution, we have to then put them in water. So now that the pennies have soaked in the solution, we're going to actually remove them. And as you can see, the pennies are now significantly cleaner than when they went in. And before we dry them, we're going to actually put them in water to finish the process up. And while those are soaking in the water for a moment, we're going to take the nuts and actually place them in the solution. And what you should see happen is the nuts should actually start to get darker in color because they are now reacting with the copper oxide that, or excuse me, not the copper oxide, with the blue copper 2 that is in the water. So we will take these out, place them to the side, and we will actually pour the water and the pennies out. All right. And I will now show you the finished product. And now here you have these same pennies that actually went in, and they are significantly less oxidized than they were when they obviously went into the solution. And as you can see, the nuts have set in the solution a little bit longer, and they've gotten darker, and I will explain why this happened in a moment. So now that I've performed the experiment, I can explain a little bit more of kind of why what took place happened. So copper oxide forms on pennies when they're left out in the air because copper and oxygen combine to form copper oxide, and this forms in the air. The acetacidic acid solution or the weak acid solution that's found in the vinegar, along with the salt, dissolve the copper oxide on the pennies, and it makes them look new or shiny, which we saw in kind of like the aftermath. When the pennies are placed in the water, the reaction stops because it neutralizes the acid. When the pennies are put back on the paper towel, over time you'll notice that they'll turn kind of green or blue, not necessarily rust color, but that's called malachite. And malachite is a copper carbonate hydroxide mineral that is caused by the copper combining with oxygen, as well as the chlorine atoms that are found in the table salt that's used in the experiment. When we put the steel nuts into the vinegar and salt mixture, some of the iron dissolves, and the copper atoms and the iron atoms both leave electrons behind. As a result, this creates kind of a imbalance of the charge, and it causes the positive charged ions of the iron to float in the salt and vinegar mixture with the positively charged copper ions. The nut that's still in there is neutral, and the iron ions that are left behind are negatively charged, so they will pull any remaining positive charges back towards the nut, and that's how you get the darkish color on the nut. Essentially, you could repeat this experiment with the nut and remove that, but that is why what happened. I hope I did a good job of explaining this, and I hope everyone is well and safe. Take care.